Okay, so you guys can hear well, right? So let's start that. So good afternoon, ladies and gentlemen. Thank you for coming to our presentation today. And as you have said, that we'd like to introduce about the lithicis sponge microbial reef building consortiums in the middle to late Cambrian successions and discuss their paleoenvironmental implications. Before the main story, let's remind ourselves about the reef evolutions. You may know of this famous diagram, which were written in the book Facies Model, written by James and Wood. And as you can see from here, that during the Precambrian, we had abundant stromatolites, which were formed by the microbes. As we get into the Phanerozoic, we have many different kinds of the invertebrates and algae which had formed the reefs. The Cambrian and to the Middle Ordovician, that was a transitional period. During this time interval, we had both microbes and invertebrates forming the reefs together. Details of this time interval were presented below, and I'd like to talk about it a little bit more. Prior to this diagram, we had some of the early skeletal metazoans within the microbial dominant reefs, and that would be the Claudina. And by the early Cambrian, we got the Archaeocyath sponges, the famous ones. They formed the reef together with the microbes, and probably they were one of the early skeletal reef builders which have formed the reefs together with the microbes, just attaching together, forming the solid frameworks. But by the end, about the end early Cambrian, they got extincted. It has been traditionally thought that the microbial carbonates were the dominant reef builders during the middle and late Cambrian, as you can see from here. Only the dark gray colored microbial reefs. By the early Ordovician, we got the lithicis sponges within the reefs, together with some other organisms such as calatheons, which are thought to be a kind of sponges, and some primitive corals, stromatopores, bryozoans, and so on. But they never became dominant until the late Middle Ordovician, when they could have formed the reefs solely by themselves without any microbes. You may feel a bit interesting that why I had colored that there are 40 million years gap between the Archaeocyath and the complex mid-Ordovician reefs, because that this diagram needs to be changed like this. In recent 20 years, we got the many reports of the sponge microbial reef from the middle to late Cambrian deposits, and that successfully goes into the early Ordovician. So I have said that there are some differences in the middle to late Cambrian and early Ordovician stuffs, but that was a traditional view, and we now need to change our view on it to having many lithicis sponge microbial reefs. Let's look in more detail about it. These are some of the things that I have published last year. And as you can see from here, at the about end of the early Cambrian, Archaeocyath got extincted. But almost immediately after that, of course, there are a little bit few million years of gap. The lithicis sponges had formed the reefs together with microbes from the base of the stage 5. They occur from the almost all stratigraphic horizons from the base of the Middle Cambrian to the almost end of the late Cambrian, and they occur worldwide, from the China to the USA and other places such as Australia and Iran. So they are quite much widespread, and they successfully occur within the Middle and late Cambrian successions, as well as lower Ordovician. These are some details of the sponge microbial reef that we can see from the middle to late Cambrian successions. You see the donut-shaped structures there? They are the transverse course of the cone-shaped sponges. They are quite much dominant within the reefs, and as you can see that they just form closely nearby, attaching together, forming the solid frameworks of the reefs. But at the same time, you see some of the dark colored stuff here, like for example, you see some dark colored micritic stuffs, which are microbial carbonates. And if you look at up part here, you see some clothed, some dark colored stuffs that are also the microbial carbonates. If you see the photo on the right here, you see the laminated structures. They are microscopic stromatolites. Right above that, you see the flat-lying sponges there. So from these kind of examples, you can see that the sponges and microbial carbonates were closely acting together, forming the reefs of this time interval. These are some more details of the microbial carbonates here. You can see that they grow on these sponges, just growing on top of it, or they may just grow below the sponges, filling the interspaces in between the sponge frameworks. So these two are one of the major and integral components of the middle to late Cambrian reefs. In this diagram, I'd like to show you the major component changes throughout the Cambrian and the early Ordovician. In this one, the archaeocene microbial reefs, we have many different components here. We have some dark violet colored archaeocene, and at the same time, we have some calcified microbes in green color, some lighter gray green, which are microstromatolites and the other kind of microbials, some sediments in between. And in the early Ordovician stuff, we also have many different kind of the organisms within these reefs. I'd like to say just one thing first, that the one in the early Cambrian and the early Ordovician are the summaries of many known studies, so these are some generalized view. But in the middle and late Cambrian, they are each of them are from the single example, so I'm showing you some precise examples of it. In any case, you can see that there are many different bars here in different colors in the early Cambrian and early Ordovician. But when you get into the middle and late Cambrian, you see that the number of the bars get decreased, just dark green, light green, and blue, which means that the diversity of the reef building fauna has been not that high during this time interval. Also, as you can see from the archaeocene reefs, I just have drawn just one bar here for the archaeocene, but in many cases, we have several different taxa several different species of the archaeocene within one even single archaeocene mound. So it seems that the diversity of the reef building fauna has been decreased from the early Cambrian to the middle Cambrian. Well, this diagram would be a little bit complicated, so I'd like to present something more simplified one. The pie chart down here shows the relative proportion of the microbial fauna in green and the skeletal components in blue. And you can see that in the early Cambrian, we have some more portion of the microbials than skeletals. That's similar by the middle Cambrian, but as we get into the late Cambrian and early Ordovician, we began to have more skeletal components. This trend can be correlated with the reef sizes as well as the sponge sizes, which form the frameworks of the reefs. The green colored graph shows the reef sizes, and the dark blue colored graph shows the sponge sizes. Well, it seems that there are some decrease across the early to middle Cambrian boundary there, decrease in the size of the reef, decrease in the size of the sponges, but they just gradually getting recovered, gradually getting increased till the early Ordovician. Well, anyway, that I just like to show you the general trends of the reefs in the early Cambrian to the early Ordovician. But as you can see from these diagrams and the figures ahead, it seems that the Lithicis sponge microbial reef building consortium was present, and they were quite much abundant throughout the middle late Cambrian to the early Ordovician. So this is it. Well, we had the archaeocene microbial reefs, which were dominant in the early Cambrian, about 20 million years. And we now know that the Lithicis sponge microbial reef building consortium would have been dominant for about twice more, 40 million years. It has been traditionally thought that the transition from the archaeocene microbial reefs to the microbial dominant reefs of the middle Cambrian has been thought to be related with the extinction of the archaeocene. But it seems that we have the 40 million years of the Lithicis sponge microbial reef supremacy, and that seems too long to be solely explained by the extinction of the archaeocene. For example, we have the end Permian mass extinction, which is one of the largest in the entire Phanerozoic, and it only took 3 million years for the metazoans to be recovered from that extinction event. So we need some kind of different explanation. We suggest that the low oxygen levels of the middle to late Cambrian would have been responsible for such trends. You may notice that this black bar here, indicating the relative occurrences of the black shale, was quite high in the middle to late Cambrian. This was first noticed by William Berry in 1972, and he noticed that there were relatively more amount of the black shale in the middle to late Cambrian than the early Cambrian or early Ordovician. At the same time, we have some other anoxic events. For example, we have the spice band across the Middle and Lake Cambrian boundary, and recent sulfur isotope analysis by Benjamin Gear and the others suggests that there would have been some low oxygen events across this boundary. Also, we have many other some small extinction events of the trilobites and the other organisms during this time interval, of which at least some of them could be ascribed to the low oxygen events. So we were suggesting that the low oxygen events of the Middle to Lake Cambrian could have been responsible for such dominance of the spongy microbial reefs. In the modern environments, we know that the sponges are capable of withstanding the low oxygen conditions. The experimental studies suggest that they can survive within the anoxia and could even tolerate the hypoxia conditions. And that's same for the microbial carbonates. But the other reef builders, such as corals, cannot even withstand the hypoxia conditions at all. So we are thinking that the diversification of the other reef builders could have been delayed by the low oxygen conditions of the Cambrian. So in that case, what could have been caused the low oxygen conditions of the Cambrian? That could be the good question. And we all know that the sea level was high during the Middle to Lake Cambrian, resulting in the formation of the extensive carbonate platforms. At the same time, we had the high CO2 level there, and together we had the elevated temperatures during the Cambrian. This widespread carbonate platform development resulted in the development of the extensive epeiric carbonate platforms on Laurentia as well as the other parts of the walls. And these epeiric platforms were very shallow but very extensive. They were probably less than just 10 meters deep or so, but they were like several thousand kilometers in width, which means that the water circulation would have been very, very bad in that kind of very shallow carbonate platforms. But as we have the high levels of the CO2, we would have some elevated level, increased productivity of the marine planktons in the shallower part of the water columns. But because of the high temperatures, the oxygen solubility to the seawater would have been quite low. Altogether, we would have some thermal stratifications within these shallow carbonate platforms, and they would have been, these shallow shelves would have been prone to the episodic hypoxia, at least at the lower part of the water columns, which would have been responsible for the dominance of the sponges and microbes. This diagram shows, which has been published about 9 years ago, shows the temperature changes in the early Ordovician to the middle Ordovician and onwards. These were done by the conodonts, and they did some oxygen isotope analysis on these conodonts, showing that the temperature would have been declined greatly. From the early Ordovician, we had about 40 degrees in Celsius or something, and by the middle Ordovician, it decreased up to the 30 degrees in Celsius or something. This decrease in the temperatures would have induced in the increase in the solubility of the oxygen, eventually resulting in the ventilation of the seawater and diversification of the organisms in the early Ordovician. So let's summarize our talk. I have told you that we have many listed microbial reef building consortiums in the Middle to Lake Cambrian as well as the early Ordovician. And this abundance of the listed spongy microbial reef building consortium would have been responsible to the low oxygen conditions of the Cambrian and their tolerance to the low oxygen conditions. But by the Ordovician, when the temperature gets cooled, and when the ocean when the seawaters get more oxygen into it, the organisms began to diversify and gradually substituted the microbial sponge reef building consortium of the Cambrian and early Ordovician. That's the end of our question. Thanks for listening, and we welcome any comments or questions.